Now see here, this is the concept of equilibrium of a rigid body. So any rigid body is said to be in equilibrium if its linear momentum and angular momentum both does not change with the time. It means the body has neither linear acceleration nor angular acceleration. Then we can say the body is in equilibrium. So here the first concept of this, if you have taken here total external force is equal to 0. So sum of the external forces acting on the body is 0, then we say the body is in translational equilibrium. It means if the vector sum of all the forces acting on the body is equal to 0, then the body is in translational equilibrium. Second one you can take similarly, if the sum of the external torque is equal to 0, it means the total external torque acting on the body is 0, then we can say body is in rotational equilibrium. So for the equilibrium, these two conditions you have to see. First this one for the translational, and for the rotational equilibrium this one is here. Now we will be doing examples or related to equilibrium of a rigid body. Now see equilibrium of rigid body, we have seen two conditions. Now we will take an example. Suppose this is a rod, you have taken rod AB and this is the center C. This is A and B rod. And one force is acting this side F and one force is acting here, this is F here. Example of seesaw. In that case, if you see here, the sum of these forces cannot be equal to 0. Both are in the same direction, so that is not equal to 0. It means body is not in translational equilibrium. But if you take this distance is A, this is A. Now torque is equal to, that is A into F, is the perpendicular distance about the from the axis of rotation and line of action. So this is the line of action, this is the axis of rotation. So torque is equal to A into F. This will try to rotate to this side clockwise and this will try to produce torque in the anti-clockwise direction. These both the torques are equal but opposite in direction. So the net torque will be here, sum of the torque is equal to 0. It means this body is in rotational equilibrium. Now let us take another example. Similar way, suppose you have taken a rod in the same manner, this is the rod AB and this is the point C only, that is the center. One force was acting to this side F and this distance is A here. Now just I have reversed the direction of the another force, F is here this side and this is also A here. These two forces are equal in magnitude and opposite in direction, so obviously net force is equal to 0. It means body is in translational equilibrium. So this body is in translational equilibrium. This is rotating the body to this side and this is also to this side. So both the forces are providing torques in anti-clockwise direction. So the net torque cannot be 0. So that does not equal to 0. It means body is not in rotational equilibrium. So these two forces are producing the torque or rotating the body about the point C here. This type of the pair of the forces which are rotating the body about a fixed axis and there is no translational motion at all. So these type of forces are known as couple. So if this condition is found, then these forces are said to be couple. So they are the pair of the equal forces acting opposite in direction, having different line of action and not producing any translational motion. So this system is in the translational equilibrium but not in rotational equilibrium.